Hey, everybody. How's everybody doing this evening or afternoon, depending on where you may be in the world? Just thought I'd do some more live streaming rather than playing video games on a Saturday night or going out and partying, even though there's no place to party. So, just gonna let people know that we're going to go live for a little bit. So I'm just creating some social posts here quick, and we will get started. My thumbnail, hilarious. Okay, let's see. Oh, I need LinkedIn. Got to do LinkedIn as well. I'd like to do this every Saturday night, but sometimes I get scared of commitment every single week. It would be cool though. Definitely keep me in the habit. Great. I'm going to share my screen. Actually, let me move this stuff over here. Just going to minimize this. I've actually hooked up my iPad as well. So if we do some math that we can actually, I can actually write it down on the iPad. We can get fancy. So, cool. Yeah, so I've been working on this synth for a little while now. And I think that, let's see, where am I going to put myself? I'll put myself up here. And it's looking pretty cool. Worked on it a little bit yesterday as well. And so I've, let me show you what I've got, just in case you haven't seen it before. This is it, 2 oscillator synth, and it's got a low pass, band pass, high pass filter. And we've actually got a filter LFO, filter ADSR as well, and a regular envelope ADSR. And we've hooked up the juice reverb as well. And then yesterday I put the image on this, and then I created this meter component. And this isn't hooked up to any audio yet. It's actually just a couple simple rectangles. So yeah, so it's a couple simple rectangles, and we need to somehow get some audio levels in here. So just thinking about how to do that. And yeah, I thought it'd be a cool thing to live stream, and maybe some people will have some helpful hints if I get stuck, or maybe it might be helpful for you if you're just getting started out and you want to learn how to build your own audio plugins and audio apps. So sometimes I think it's good to go outside of the tutorials and to try to do some things where I show the thought process that I go through when I'm actually creating some of these tutorials and some of these things. And I'm not an expert by any stretch of the imagination, but this will help you get started if you're a person who's just getting started. So without further delay, let's have a think about this. So I will show you my meter class. So like I said, it's just a couple rectangles. So if I go to meter component right now, you can see this is really how simple it is. And it's just like this. Basically, I've got this in my paint method at the moment. And then I have a left meter where I've essentially, what I've done is I've taken the whole, the dimensions of the whole component, and I've reduced it a little bit, and I've moved it slightly down, and then I've drawn two rounded rectangles, and that's how you really end up with what we have there. So you can see here the code and what I have. So you have a left meter, a right meter, and then you draw two rounded rectangles. That's really as simple as it is. That's really it. So I'm just going to take a picture here so I can put this on our Instagram. And before we really get into it. And 1 moment. So the audio programmer. Okay. Cool. So yeah, without further delay, let's go ahead and get into it. So what I'm thinking, a good place for us to start, I'm thinking of doing some levels. So I'm thinking that hopefully we could do two types of metering. Peak metering, where we take the peak amplitude of a signal, and then RMS, which is essentially the average of a signal, so root mean squared. And we're going to probably pull out some reference materials that I have here at the flat to help us figure out exactly how we're going to do it. I'm not a DSP engineer by any means. I know a little bit of math, a little bit of linear algebra. So hopefully, fingers crossed, that will get us far enough. Cool. Let's go ahead and kick into it. So I think what I'll do is I will start here with some paper. So what we have here is my iPad, and we will start by saying, okay, so we have RMS, which is root mean squared. So what I'm thinking, so I'm going to start off with my naive understanding of this, and see if that's the correct understanding, and then we'll see if we can implement that. So my understanding is basically we would have an audio call. So if we go to our audio callback, unfortunately, I can't switch back and forth like this. So if we go to our audio callback, our process block here, essentially we have this buffer that's going to be full of synth information that we're going to be filling this this audio buffer with audio information. Now, what we need to do is we need to find out exactly what the levels, what the amplitude of that signal is. And that will help us determine what we need to do is we need to find a way to record that and then somehow pass it over to our meter component so it can actually display it on the screen. So the first step would be one, getting, so we'll get an audio readout. So we'll do that. For RMS, what we'll do, we'll need to figure out the RMS formula. So that, I imagine, would be something like taking the absolute. So we're going to have, so we'll come back to that. We'll come back to it first. And then 3, sorry, you should be seeing this. So we got get the audio readout, figure out what the RMS formula is. And then, of course, we're going to implement that formula. And then we have a way that we need to relay those values to our visual component where the user can see this out of the meter. So pass to UI, user interface. Okay, so those are our steps for RMS. Get the audio. First thing we need to do is get the audio readout, figure out what the RMS formula is, implement the formula, pass it to the UI. Seems simple enough, right? Let's give it a go. So, just going to pass this over here so we can get started. So our first step, get our audio readout, right? So that seems pretty simple. So I guess one question we should ask is, do we want this to happen pre-reverb or post-reverb? I would imagine post-reverb would be the way we'd want a reverb signal to be in there. So I'm just going to start off really naive, and I'm going to just say, I'm just going to start off with a for loop where we actually just get the values. So we could say for int ch equals 0, ch meaning channel. Channel is less than buffer get num channels plus channel. And then we would have a for int sample. What should we call sample? Sample, I'll just call it S, equals 0. S is less than buffer get num samples plus S. And if we were doing something that we weren't supposed to be doing, such as consoling this out, so we're not technically supposed to console out the, who's messaging me? Oh, I love how Florian just gives me the answer. Come on, Florian, we're supposed to figure this out together. Come on, man. So if we were going to do something we weren't supposed to do, such as consoling out in the audio callback, which is something that we're not supposed to do because that can cause disruptions in our audio stream, then what we would do, or what we would do that we're not supposed to do would be something like buffer at sample. So let's see. So that would it be just that? Oh, it would be something like this, buffer CH S. Right? So thing is that the buffer has a read pointer that we can use to actually get this. So we could say auto B equals equals buffer get read pointer, and we can just get the channel number here. Let's take a look at our documentation here so we can actually see what we're looking at. Everybody's quiet tonight. Oh, what's happened here? I want to make sure that Florian was saying that he can't see what's in the chat. Can people actually write in here, or is it stopping you from writing? Anybody? Somebody? Just want to make sure that people can actually use the chat, just in case they have questions. I've heard that this has been a problem before. So I wonder if I could turn the chat off and then back on. Oh, yeah, cool. So it looks like it's working. Awesome, great. So let's go back to where we were. So, okay, so let's go to the Juice API, right? So I'm walking through this because I know some people are just getting started. So this is more for people who are really just starting to see how some of these things work. So what I'm going to do is I want to read the values of the buffer. So here we have this function called get read pointer, where we can actually get a read pointer to the buffer, and then we just need to iterate through the actual buffer to actually get what the value is at that particular point. So we got, I'll call this output. I never know what to call these things, the best name for them. So we got auto output equals buffer get read pointer, and then we want to say output S. So that feels right, right? I hope. So we're going to try this. We're going to once again do something that we're not supposed to technically do, which is outputting to the console. And I think that is it building? So trying to build this here. Oh, good to see that the chat's working. That's good news. How's everybody doing this Saturday afternoon or Saturday evening, depending on where you're at? Okay, just waiting for it to do its thing. Okay. So here we are. We're in TAP synth. And I'm going to switch the output so you can actually hear this properly. Output output is there. Hopefully this doesn't sound too... Okay, so that's the reason why you don't console out of in your audio output. You hear how it has those, how it's kind of stuttering there like that. So that's the reason why you don't want to do that. So what we're doing is we're looking to see if there are actually values that are coming out of this when we actually play the synth. Great. So far so good. Oh, you got some food that's being delivered. What kind of food are you getting? I've been staying healthy, so I got chicken noodle soup for dinner tonight. Yeah. So when I hit this, we see that we're getting values coming out of that synth, which is awesome. That's exactly what we want to see, right? Now, if we go back up here and take a look somewhere, there it was. Okay, we see that these values are between. So they're really should be between -1 and 1, right? Because they're a waveform, right? And that's what we're doing. Okay. So now we got a problem, which is that the waveform of a signal. So going back to our chalkboard here. So this is cool. We got audio that's coming out now. And now we have these values. So I'm just going to draw a line here. Excuse my very messy handwriting as well. Yeah, I have very messy handwriting, so I apologize that my writing isn't as elegant as some other people's. So we have these values that are going between -1 and 1, right? Now what we want to do is we have this this RMS, which is going to mean like an average. So we need to find the average amplitude. Thing is that when we're actually displaying it on the meter, then what we need is that -1 to actually be the values that are below 0 to be positive, actually. So we could probably do that two ways. So this is just my thinking. We could square it. So we could say if X is equal to a sample, then maybe what we could do is we can maybe say X squared and then take the square root of that later, right? Because if we had -1 squared, that equals 1. Then if we took the square root of that, that would be 1, right? So that's one way. Another way that we could do this is, I'm thinking that we could do the absolute value of it as well. So we could probably do the absolute value. So once again, I mean, I think that would give us the same results, right? So if we were taking all negative values and just taking the absolute value of it, then that would give us all positive values. And then what we could do is then we could just take the average of all those values, right? So we would, so it seems like there's a 1 over, I'm just thinking random thoughts at the moment. So we got 1 over n values, so we're going to have to do sorry about this. Let's say n is equal to number of values in a callback. So maybe it might be 256, maybe it might be 512. And then what we would do is we could add all of the values together, right? So we could say every one of these values, we do like a sum of all of them. All right, so we sum all the values in the callback, and then I've forgotten one small little thing. Sum the absolute value of all values in the callback. And then divide that by the number of values. All right, so just taking this a step further now. So let's see if we can make this a little bit more succinct. So so let's see here. So we would have, let's call this float sum equals 0. This would need to reset every callback. Then we would say for each sample, then we would say sorry, going to go back a step here. I forgot something again. For each absolute value of the sample, then we would say sum plus equals sample, basically. Then when it comes out of this loop, we would say sum. So, sorry, we would say RMS equals the sum divided by num samples. Yeah, that feels. Trying to think of any holes in that logic there. Anybody think of any holes in that logic? That feels pretty. That feels pretty good. So sum every callback sum is equal to 0. So let's see. So that feels like that goes in the. That can be just a local variable to the audio callback. Cool. Let's try doing that. Yeah, I see you're talking about food. So you're asking how chicken is healthy. Well, I actually do weightlifting. Yeah, so that's why I actually eat so much chicken. It's yeah. Chicken's pretty healthy though, right? I mean, if you're eating like chicken breast, that's pretty healthy. So let's follow our steps here. So we would say float sum is equal to 0. We could say this is running total of all samples in the callback. And then we go down here for all of our channels, get the read pointer for the channel. Now, for now, so one thing that I'm thinking is that this is going to take the sum of both the channels, right? So yeah, so this is gonna be the sum of both channels. Later on down the line, we could probably separate that out to left and right. But for now, let's keep it simple and let's just do one RMS for both channels, just try to keep it simple. So now we have this. So we're going through our channels, we're going through our samples. We got this output S. So I just need to see if this is going to happen in all in this loop here. So we got sum plus equals output S. And then once it comes out of that, so let's think about this here quickly. So this does, yeah. So this would just give us, okay, let's just do this really quick and then we'll come back and we'll think about it. Right? So since this needs to be read by the UI thread, this will need to be atomic. So because we have the audio thread that's going to be writing to the value, but then we have the UI thread that's going to need to read from the value, right? And I'm sure that there's probably a fancy way that that this could probably be put in a FIFO. You probably don't need every value. No, you would need every value. Yeah, because you're gonna, no, you don't need every value because you're gonna have audio callbacks, because audio callback is going to be spinning faster than the UI is going to be repainting. But I think for now, I think that's going to be okay. I don't see why that's going to be why that would be a problem. So I'm going to do a stood atomic float RMS. Can I initialize it like this? And then RMS dot store then this would be sum divided by buffer dot get num samples. I once again forgot to do this to do this one thing, which is that I'm going to do auto abs equals stood abs. So we got a stood. We got absolute value function that we can use in the standard library called stood abs. So this will do that will take the absolute value and then we will add it to the sum. Yeah. Oh, sorry, this needs to be output as like that. Yeah, so let's compare what we have. And then I will go to comments. Okay. So we got the float sum resets every callback. Then for each absolute value of the sample, sum plus equals sample, and then RMS equals the sum divided by the number of samples at the end of the callback. And that's stored in our atomic. So that feels fine. Yeah. Okay, so let's see what people have to say here. So we got a lot of food talk. What would happen if you hit a 0 and tried to square root the 0? Would it equate to 0 or throw an error? So square root of 0, Jason says square root of 0 is defined as 0. That's correct, because 0 times 0 equals 0, right? So I don't see why that would be a problem. And then let's see, Florian based in says, is it dividing by numbers at the end? Why did I think it's 1 over square root? I think that it was something I needed in a project once. Yeah, so I thought that yeah, abs would definitely be needed because otherwise you're just going to have negative numbers, right? So if you have the amplitude at one point that is minus 0.8 and another point where it says 0.8, the amplitude of those two signals is the same, right? So, but if you were adding those two things together, then it would equal 0, and that would not be right. So that's why you would need, there's something missing here. So let's take a look. Is there something missing? Let's have a look. I like to do very simple use cases here and see if this plays out, right? So let's say that we have 4 values, right? So let's say that our buffer was just a size of 4 and we had minus 0.0.8 0.8 minus 0.12, or yeah, 0.12, and 0.5, right? So let's get out the calculator really quick. Where's the calculator? See, the thing is that this always takes, there it is. So we got, so this is what I mean by, so we got minus 0.8 plus 0.8, that, wait, minus 0.8 plus 0.8, that gives us 0, right? So this is if we didn't take the absolute value. Minus 0.12 would give us minus 0.12. And then, so, sorry, minus 0.12, sorry, minus 0.12 plus 0.5 gives us 0.38. And then we have to divide that by 4 values because we want the average of that. That would give us 0.095. Okay. Now looking at these values, that clearly isn't the right answer, right? You know, should be probably around 0.6 somewhere. My like rough eyeball of that says that the answer should be somewhere around 0.6-ish, right? So let's try my way, which is the absolute value of this. So we got 0.8 plus 0.8 plus the absolute value of negative 0.12, which would be 0.12 plus 0.5 divided by, so that divided by 4 equals 0.985. That's not right either. So let's see here. So let me do that again. So 0.8 plus 0.8, that'll give us 1.6 plus 0.12 plus 0.5. So that's 2.22 divided by 4. There we go, 0.55. Yeah. So that's why, so that works there, right? So remember my rough eyeball was saying 0.6-ish, and that gave us a 0.55. So that's why that works. Okay. So let's see here. So Ethan says, for RMS, you may need some sort of power function, something times something, which would be an exponential result. Yeah, the area under the curve. So even negative values have area under the curve. Yeah, but that's why I'm doing absolute. That's why I'm doing the absolute value of that, right? Because that would give you the same. That would give us the same results, possibly, right? So let's try it. Let's try it that way, right? So let's say, let's do. I think we're just going to get to the same solution, but let's give it a try, right? So we have negative 0.8 plus, so that's squared, sorry, plus 0.8 squared plus negative 0.12 squared plus 0.5 squared. So this would be 0.64 or 0.064. So let's do 0.8 times 0.8 equals 0.64. So we got 0.64 plus 0.64 plus 0.24 plus 0.1, which will give us 0.128 plus 0.34, which will give us, sorry, my math is terrible. So we got 0.128 plus 0.34 gives us 0.4. No, I did something wrong there. So 0.64. See, this is what happens when I don't rely on the calculator. Plus 0.64 plus 0.24 plus 0.1 equals 1.62. And then we do the square root of 1.62. How do I have a square root here? So sorry, I'm gonna have to pull up my Safari here. So 1.62. So we do square root of 1.62. I feel like I did something wrong there. Okay. I really think both of those things should get you to the same answer. All right. So 0.8 plus, so 0.8 times 0.8 gives us 0.64 plus 0.64 plus, it's my math. 12 squared is 144, not 24. So plus 0.144 plus 0.1 equals 1.524. Man, what am I doing wrong here? So 0.64 plus 0.64 is 1.28, not 0.128. So yeah, so I'm right there. So I'm right. And then I got 0.12 times 0.12 gives me 0.0144. 0.0144. And then we got, of course, 0.5 times 0.5 is 0.25. Oh boy, my math is rusty, people. Sorry about this. So now 0.64 plus 0.64 plus 0.0144 plus 0.25. Oh, this still isn't right though. This is still not right. What am I doing wrong, everybody? Yeah, I don't really use Desmos, unfortunately. It's 0.8 times 0.8. That's 0.64. 0.64 plus 0.64 equals 1.28 plus 0.0144 equals 1.29 plus 0.25. Oh, I forgot something. So that's 1.115. So then we take the square root of that, which gave us 1.234. So we got 1.234, and I just need to divide it by 4. Sorry. Divided by 4 equals 0.3. Okay. Let's look at yeah, so it's root mean squared, which means that you have to square it, I guess. I guess it helps if you look at the formula for this. So let's have a look here. I'm looking in Eric Tarr's Hack Audio book here. So root mean squared is 74. Let me just go here. Thanks a lot, Ethan. It's all good. You're all helping me. Yeah, so according to Eric, looks like Florian is right here. So RMS, so let me just flip to another page here. I'm just going to write this down. So A RMS is equal to, sorry, I'm trying to hold the page in my book at the same time that I am so it's, oh, you do that, then you take the square root of it. Okay, cool. Okay, I got it now. So it's the square root of 1 over n. Sorry, just gonna erase this. 1 over n of x1 squared plus x2 squared dot dot dot. Right? So let's go back to our previous page, because what we were doing was we were taking the square root of the sum and then doing the mean of that, whereas what we need to do is the mean of that and then do the square root of the average. So what we need to do is we have 1.234, which is our, no, we got 1.524. 1.524. We got to divide this by 4 equals 0.381, and then we need to do the square root of 0.381? Really? That doesn't feel right. Oh, 0.61. Yeah. There it is. Yeah, and we were saying that the answer should be 0.6-ish. So there it is. Okay, so let's just go through that one more time, right? So we got 0.64 plus 0.64 plus 0.0144 plus 0.25 equals 1.5444. Then since we have 4 values, we need to divide that by 4. 0.3861 gives us a RMS of 0.62. Okay, so yeah, so that feels, so we're just going to have to adapt this. I'm not sure where I got stood. Maybe I was thinking of peak value there. Okay, so let's do square root of each one of these values. So auto square root equals, so I heard from a DSP engineer that it's actually that that using this square root function in the std library, the standard library, is actually quite slow. So you want to do this output s times output s. And then we will get rid of this. And then we will say sum plus equals. So let me see here. So I want to make sure this is right. Sum plus equals square root. Then we, and then once that's finished, we could say auto average equals this. Sorry, I meant the this is squared sample. Squared sample. And then, so then we got sum divided by that. And then now we just need the square root of average. So was it stood square SQRT average. Right, so that feels right now. Okay, yeah, but we're not doing separate ones for each channel just yet. Yeah, so this feels right now. So we're taking each sample, we're squaring it, we're adding it to the sum. Once we get done adding to the sum, then we divide it by the number of samples, and then we take the square root of that. Yeah, that feels right now. Yeah, anybody got any objections to that? Yeah, so that feels right now. Okay, so now we've done that. So now let's go back to our plan after a little bit of toing and froing. So we've implemented the formula. Now we've got to pass it to the UI. And we've actually got to figure out how to draw it on the screen. So what are you saying, Florian? You still have to get back to 0 for each channel, but I don't want to do it for each channel at the moment. You have to get to mid before applying RMS or divide it by some samples. No, I think it's fine as it is, Florian. Yeah, I don't see how, because it'll be roughly the same, because I know we're putting both of the channels in there. Actually, we're not. We're actually just we're doing it for each. We're doing it for each channel. We're getting an RMS for each channel, but that's fine, which means that we'll get twice as many. Yeah, we'll be getting a number for each channel. Yeah, there's no problem with that. Don't see any problem with that. And then we can separate it out by left and right channel a little bit later. But for now, we'll just have it all in the just in the same channel, just left and right. So, okay, so now what we need to do is we need to have RMS being public, so we could, maybe not public, but just where we can actually get the value of this. So I'm going to do const stood atomic float reference, and this is going to be get RMS, and then return RMS.load. Yeah, that feels right. So now we need to go to the meter, and I need to give the meter access to either the audio processor or to just the RMS value. So let's see, let's have a look at how we've done it for other. So for other ones, we've done the audio processor value tree state. Yeah, I need to give access to the whole audio processor. So it's going to be, so I need to say juice audio processor, or I'll just call it P. We need to give that to our constructor here. And then we need to create a reference to that with juice. Let me see, does this have to be so let me see, one moment here. So this has to be a tap audio process. Yeah, so it has to be like this. Sorry. Has to be my audio processor. What the world is going on here? 1 second. So this has to be to my specific audio processor class. Here we go. There we are. And here we are here. And then back here again. Audio processor. And then I just need to pass that in my initializer list. Audio processor. P, like that. Oh, I need to, let's see, do I need to give access to the plugin processor like this? So here we go. So it knows what my audio processor is. Oh, so this would be, sorry. Can I do .. /source? Or no, .. /plugin processor. All right, let's try that. Okay. Yeah, so I need to, so in my meter, now I have my meter that's in my audio processor editor, right? So here it is. So I need to do this. And then I need to pass in my processor and my constructor like this, meter, audio processor. And now we should be fine. Okay, just building. And cool, so that build succeeded. Yeah, I think you're right, Florian. This should not be rms.load. This should just be RMS because we're actually giving it the whole stood atomic float. Great. Okay, so let me just make sure that that warning goes away. Yep, looks like we're good. Great, fantastic. Okay, so now we've passed that on, and then now we have the reference to our audio processor, and then now let's just make sure that, so I'm going to say auto RMS equals audio processor dot get RMS. I'm actually going to make sure this is recognized as an atomic float. Atomic float. I'm not thinking today. This should be const, actually, because we're just reading from it. Yes, so here we go. So that should be const. We don't need to change it. We don't want to change it. And now we just need to think about, well, let's just make sure that it actually is coming in, right? So we will do rms.load like that. Just make sure that this is actually coming in. So, okay, so let's just try that out. Hey, I hope people are finding it helpful. We always have a little bit of stumbling. Nothing ever quite goes to plan, but here we are. So we building? Okay. Got somebody pinging me. Great. So Ableton is loading. And then we're taking this. Now it's loaded. And now when I play this, we're not getting anything. Okay. Interesting. Okay, so I know I have a feeling why that's happening. I think if I have to take a guess why that's happening, I think it's because I need to have a timer on the audio processor, on all of our painting, basically, because I don't have a timer at the moment, because I didn't need one before. So now I'm going to implement a timer. Something I actually think I saw the other day was that an audio, I'm not sure if I saw this properly or not, but I thought I saw somewhere that an audio processor editor is a timer. Just going to take a look at that. Is a component a timer? No. Yeah, it is? Okay. Yeah, it doesn't seem to say so. Normally I inherit from timers, so cool. That's interesting. Okay, so then if that's the case, then I need to do the timer callback. So let's do timer. I'm not seeing the component class in here though. Audio device, audio visualizer component, da 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 da. I'm just going to try to override the timer callback and see. I don't think it is actually. It'll flag us if it doesn't work. So void timer callback. Suppose I could just look in here. Oh, I hate when it does that. It doesn't take me to the place where I want to go. Here we go. Components, then component is a mouse listener. A mouse listener does it. So it doesn't look like it is. I'm just going to try it very quickly, but I don't think it is actually. So timer callback, override. And if it isn't, then we will, because, yeah. Well, let's see. So void TAP synth audio processor editor, timer callback. So I'm just going to try building this. Okay, yeah, so build failed. Yeah, only virtual member functions can be marked override. So we just need to inherit from public juice timer. And then we need to start the timer. Start timer hertz. So I will do it just at 30 hertz. Then I will stop the timer. And then in here, I'll just put repaint. Okay, so let's see here. So, okay, so let's see if that fixes our RMS problem or not. So here we go, down here. There we go, boom. So I'm just gonna put that a little bit bigger so people can see. So now we have RMS. So now we just need to actually display it on the in the actual in these actual boxes. All right. So let's see how we can do that. So let's go back to our meter component. So we'll just do a simple one for now. Let's see, how can we do this? So we've drawn those, right? So I got an idea. Here. So what if we did G.fill rounded rectangle. And then let's do, I'm just going to do it super rough for now, and let's see if we can refine it in a minute here. If we do left meter dot get left, get X, left meter dot get Y. Then width would be, okay, so this is where we're going to, that's where we're going to need our actual RMS to control what that's going to be. So that's going to need to be a mapping function, right? Then height would be just left meter that get height. Then corner size will be 5. So I'm just going to put this down here. Just going to make this one color for the moment, just to make it super simple. So G.setColor. Let's see, what color should we make it? Should we make it like red or reddish? What was that red color that I made my let's see. Let's make it this one. Okay, so now we need to figure out a mapping function. So we need to do a JMap juice JMap. And then this will be type float, since this is a template. Then we have the source value, which would be the RMS. Where is that gone? What did I do with that? Did I actually delete that by accident? Am I in the right place? I could have swore that. Oh, I'm so funny. So, sorry. Const stood atomic float reference RMS equals audio processor get RMS. Okay. So then this would be RMS dot load. Source min would be 0. Source max should be 1, hopefully. And these all need to be floats or else it will complain. And then the target range min would be can the rectangle be 0? I think it crashes when that happens. So I'm going to say 0.1 like that. And range max would be left meter get width. Okay, and then this should be, so auto level equals that stuff. Okay, that should work, hopefully. Let us pray that it works. Okay, so here we go. And there may be a little bit of finagling we may need to do on the drawing, but oh, look at that! It works. Yes, I can't believe it. It actually works. Holy cow! And it looks pretty good too. Dang, nice. How fancy is that? Pretty sweet, pretty sweet. Right? So I'm not going to get fancy just yet and do the and do separate channels yet, but I will do those at a later point. Right meter, and then this would be right meter level, and then right meter. Pretty cool. Yeah, that looked pretty good. I'm going to do that again. Let's do the let's get it up there. Not too bad. Had a little bit of yeah. Pretty cool. Yeah. So Florian, what would you do rather than map? I love map. Map is like I love mapping. Hey, what's up? How's it going? Um, okay, so nice. That was cool. Now um let's do a shall we do peak? I think we could do peak pretty easily. So um I'm starting to feel like this needs to be classed out now. So this should probably be its own class, right? So what I'm going to do for now, I'm just going to comment, or I'm going to copy it. I'm going to comment this out, right? And let's do another one, but do it for let's do it for peak, right? Now this time I'm not what I'm going to do is I'm actually going to look this up rather than trying to just make up make up my own formulas. Maybe if I'm a DSP expert one day, I'll do that. I'll make up my own. Okay, so peak is the one. Peak is the one that I was actually thinking of, where we take the magnitude of of the signal, and then we just find out what the max of that is. Yeah. So that's really all it's about. We could convert that into, if we wanted to, we could convert that into DBFS as well. So the sum, yeah, I'm not sure if I was just looking to see if we still needed the sum of the signals of the signal, which we don't. Okay, so yeah, so what we need to do is we're just going to go back to our tablet. So I'm just going to comment this out for now. I will bring our tablet back in. And let's have a look. So bring in our tablet back into the picture. Here we go. So that is RMS. And now we're going to talk about peak detection, and we'll put a little button that would be able to switch between peak and RMS. So peak detection, we just need to essentially do what we were doing the first time around, which is take the absolute value of each sample, and we need to find the max of out of the sample each in each callback. Find max in each callback. So we could just do like something like auto max equals is current sample. So let's see. So we'll do the max. See if the max sample, if the current sample is bigger than the last sample, and if it is, then that becomes the new max. And if it's not, then we just let it go. So is new sample bigger than max, then if yes, that equals the new max. Cool. All right, so let's have a look. So going back to the code, bringing this in. So here we have our going through the channels and samples. So here we go. So might be able to do this in one line. So we have auto max equals so each time we would need to reset it on a max equals 0. And then we would say max equals output. So we need the absolute value here, auto abs equals stood abs of the output. Max equals abs is greater than max. If it's so, if the absolute value, then abs, so max, if abs is greater than max, so abs greater than max, then max equals abs else max. Right? Let me make sure I got that right. So max is equal to is the new absolute value, is the absolute value of the current sample greater than the max? Yes, then the max equals abs. Otherwise, it's equal to the current max. Yeah, so that feels fine. And then what we need is a new atomic here. So we'll do stood. Oh, just going to move this down just to see if anybody is speaking to me. Okay, so we got stood, atomic, float, peak, 0.0. And then we're going to do this, but just get peak. And then peak dot store max. Yeah. So let's just go over to the meter. And I'm just going to do the same type of thing here. We'll go through and we'll come back to this and clean it up. So just going to copy these two lines actually. And I'm going to say peak. Then this would be auto level equals peak. Just make sure that those values are going to be the same-ish, same sort of range, 0 to 1. Yeah, cool. Yeah, that should be fine. Okay, so that should actually just work. Let's just try it out, and then we will do some code cleanup. So you could optimize that by only having one readout value, except you plan on visualizing peak and RMS at the same time. Yeah, I mean that could work. I was thinking that there would be like a switch between peak and RMS. But yeah, I mean that to have them both at the same time seems cool. Yeah, that seems I think that would be pretty cool actually. Yeah, we would need to have something maybe where it we could get fancy and try to slow down. I don't know. I'm thinking too quick. Okay, so that's not quite working yet. Okay, so what have we done wrong here? So okay, let's go back to the plugin processor. Yeah, I guess they could write into the same atomic. I mean, it could, yeah, it could work either way. I don't know. I would feel like just make them one extra atomic that, yeah. Yeah. I guess it could go either way. I don't know. I guess in terms of code readability, I would probably just have two atomics, one that was RMS and one that was peak. You know, because either way, I don't know. Yeah, I mean it could work either way, really. Okay, let's figure out why this isn't working. So abs is equal to output s. This doesn't feel this looks a little bit confusing. So I'm just going to write this. I have a feeling that that's the reason that it isn't working. So if abs is greater than max, max is equal to abs, else nothing. Yeah. So if the absolute value is equal to the max, then the max is new abs. Yeah. So I don't need an else there. Just looking to see if there's something wrong there. Because the first time around, abs is going to be more than 0, so that's going to become the new max. Okay, so let's try that. Okay, here we go. this works. Still not working. Okay. All good. We ain't mad. So peak.store max. Yeah, maxes. See, that type conversion will just get you, won't it? That would have had me. That would have had me for a while. Okay, here we go. Sweet. Cool. So that works, right? So let's try them both at the same time. Let's just see what happens. And then let's just color them slightly different and see. I'm going to put this down here because we don't need some up there. We want it just close to where it's actually where all the action is happening. I'm just going to put this peak. This is RMS. And then let's just go into the meter. Let's do something creative here. So we will let RMS be what it is. So we will let RMS be the existing color. Right? So like that. Now make it that every capture has the length of exactly one wavelength of the current frequency so that every maximum capture definitely gets the max peak. Every capture of what you're saying, trying to understand what you mean by that, Florian. I'll work on this while you're doing your thing. So that's the RMS right there. And then we got peak. Evan B, what's going on, Evan? How's it going? We're just going through some metering. So now I am just seeing if we can get peak and RMS on the same wavelength here. So here we go. So now I'm just going to RMS level. Then I'm just going to change this to RMS level. RMS level like that. And then let's do, I'm going to get another color here. So we got this Don't know if I want it to be that color, but this will be fine for now. So g.setColor. So we're going to do g.setColor. With opacity, with alpha 0.5. Okay, then it's going to do peak. Let's see how this looks. Yeah, but if it's Florian, if it's taking every sample in the buffer, wouldn't it be getting the correct peak anyway, no matter what the frequency is? So I definitely see a little a little difference. I mean, there's not really much difference between the peak and the RMS. There we go. I mean, it would probably be best to have I don't know how to do this, but where it would actually kind of fade rather than just feels like it needs like a filtering effect on it. It's okay for now with it being rough, but this could use with some smoothing. It's not bad though. So let's break down what you're saying here, Florian. Sample rate divided by frequency gives you the number of samples per wave cycle. So your peak capture always has that length. It will definitely always get the correct peak. Imagine your buffer is just 4 samples long. But what do you mean by correct peak? I'm not sure what you mean by that, because it's just looking through the buffer and it's just saying what's the sample with the biggest magnitude in the buffer at that particular time. I'm not quite sure what you mean. Yeah. I think there needs to be some type of filtering or some type of yeah, basically some type of low pass filtering that would filter the values and slow down the signal, slow down how quickly the UI is changing the level. Maybe that's a problem for another time. I'm a little bit hungry. Okay. Imagine that you play a wave that has 2,000 samples for every wave cycle, but your audio buffer, then it's unlikely that the peak is in there, right? I'm not sure what you mean, because this one is just looking at, well, what's the I get what you're saying. So you're saying so you're saying rather than having the peak be per callback, having it be per waveform, per wavelength of a sample. Is that what you're saying? So basically you would have almost like a memory of the peak between callbacks that would refresh slower. Yeah. So I think we're saying the same thing, more or less. Yeah. Yeah. It would seem that, at the moment, what we have is we have something that refreshes every single callback. And as we were saying, like we were saying before, right, that like we were saying before, it's not even getting all the value. It's not even getting all the values of, it's not even able to draw all the values that it's getting from the audio callback. It's skipping over some because the audio callback is spinning at what is it? Sample rate divided by buffer size times per second. So, so this would, yeah. So I think we're saying the same thing, which is that we need to slow down the rate at which the values essentially change, which would mean that we would need to have some type of memory that would remember what the value is between callbacks and decide. There would need to be something intelligent that decides when it needs to refresh what the value is. Maybe it's one time a second, yeah. Yeah, that's the thing. Yeah. We could probably worry about that for the next one. So I'm starting to get hungry. But before we do that, I think one thing that would be cool to do is to actually subclass this out. So I'm going to actually create a class for this because I love creating classes. So let's do CPP and header file. Oh, I didn't say where I wanted these yet. So I want this in here. I'll call this meter data. Yeah, Evan. So we were just talking about. So we've created a peak and RMS meter, and now we're just talking about how we would actually go about making that smoother, because it's obviously quite jumpy the way that it's showing on the UI at the moment. And so we're just talking about how we can actually like smooth those values out so that they don't, so that the signal isn't so jumpy on the UI. And so we were talking about having like a memory that maybe we slow down how often we're trying to actually read the value from to refresh how often we're actually changing what the value is. So rather than changing at the moment, we're changing it every callback, but maybe we want to slow down how often that changes. So, and discussing the best way to do that. So, okay, so I'm just going to class this out to meter class. So here we go. I'm just going to cut all of this and I'm going to put it in meter data. Just put it here for now. Call this class meter data. And then we got public, we got private. And I'm going to take RMS and peak. So this is interesting. We're going to have to, I will come back to this. So we got meter data. We now got got those. And I need to bring in the juice header. Here we go. So there's juice header. And then we will say void meter data. Process peak. And then this would need access to the buffer. So we got juice, audio buffer, float, buffer. Don't think that it needs anything else. We will have a process RMS as well. I'll just copy these to the header. Void process. Oh, I could just paste it like that. Void. I'll just call this peak. And then this is the RMS. Where are we? Okay, so then we got this, which will be our peak. Then we will need to go, now we need meter data here. Just making sure I'm putting it in the right place. Yep. Include data. Meter data. And then in here, it would be meter data, meter, and then yeah, because it needs access to this particular instance of this object. Meter, so this would need to be meter. Hold on. So I'm going to take these, I'm going to copy these here. And now I'm going to go back here. And then meter.get RMS, meter get peak. Just wondering if, no, that's fine. And then we need to do meter.process RMS buffer, meter process peak buffer. Where did you send the picture, Florian? To my Discord? Yeah. So like basically almost like a windowing, yeah, like a windowing function almost. Right? Is that what you mean, Florian? I think that's what they call it. They call it a windowing function, right? Yeah, so we'll just need to smooth those out over time. No, it didn't come through in the chat, unfortunately. Yeah, it would just need to decide when it actually does it, because the thing is that if you had a faster frequency, then under what you're saying, then the meter would show up faster than if you were playing at a lower frequency. Yeah. Oh man, this definitely isn't Steve Duda stuff, but thank you very much. Yeah, that's nothing. That's nothing compared to what they're doing over there. This is just some basic. This is just some basic stuff. But thank you. That's like R2D2. Well, not quite, but. I get what you're saying, Florian. Yeah, that would be cool. That would be cool. Interesting stuff. Yeah, that could be one for the next. Maybe we'll do another live stream tomorrow, and we can look at how to actually smooth the meter. Yeah, I really think that it's about. It would just really be about deciding how often the value needs to refresh. So we don't need it to refresh every single callback. I think normally the pros use a FIFO to do this. And then they apply a refresh rate. I think that's how the pros do it, using a FIFO. Yeah, this is just a very kind of naive beginner's way to do it. Hey Jess, how's it going? Yeah. The big thing is that values get missed when you're doing it this way. Really, what you want is probably to like, especially if you're going to be displaying, because this is along the same lines of a concept as displaying the waveform itself. Like, it would be ridiculous to try to display all 44,100 values of the waveform in 1 second. So what you got to do is you got to sample it. Maybe you sample it once every 10 values or 16 values, and then use that to build the visualization of the waveform, because the audio callback is spinning so much faster than what the UI is able to actually represent. I guess the question is what the proper way to do that is. I think a FIFO is the way that people say is the way to do it. But maybe I'll do some research and come back with with a report on it. We'll get somebody like Daniel or one of the pros in here doing it. Cool. I'm kind of hungry, so I think I'm gonna go and chill out for a bit. So I'm gonna end the live stream here. Yeah, maybe we could do like a FFT. Oh, FFT just opens up a whole can of worms. But yeah, this is just a meter, but I think all of these things really fall along the same type of principles, which is that where are you going to take your values? How often are you going to take the values, and then how are you going to use those to display those values on the screen? Because you can't do every one, or else what happens is that you get that jittery type of display, like what you're seeing with what I have at the moment. So we just need a way to slow it down. But I will come back with a report, and we will figure it out together. So yeah, I'm gonna just push this to the repo here. So git add git commit. Created peak and RMS meters needs smoothing and improvements. Git push -u origin main. There it is. Great stuff. Yeah. Thanks, Florian, for your help on this. Yeah. Waveform display would be awesome. Yeah. Like if that could be synced to a wave cycle, that would be super cool. That would be really cool. Yeah, that could be something to work on actually. Cool. I just need to find my where my live stream is so I can actually stop it. And content. The video is pretty popular as well, Florian. Nice stuff on that. Seems like that got a pretty cool response. So yeah, good stuff. Everybody have a great night, and thank you very much for hanging out. And yeah, maybe I'll come back tomorrow. No, it's not made for kids. Trying to figure out how to actually end this dang stream. Oh, I think it's in my Zoom chat, actually. There we go. Yeah, I can end it here. Cool. Thank you very much, everybody.